Okay, so here we go, number 12. Problem says evaluate the inverse function tangent. Where does tangent equal 1? Basically, that's what's asking. In other words, how far do you have to spin your spinner to get this situation? So we're looking for theta. Yes, you could use your calculator, but I don't think that's the intention of number 12. The intention of number 12 is to make you think, where in the world, because tangent is opposite over adjacent, where could opposite over adjacent ever equal 1? The only way is when the opposite and the adjacent are equal. Then we know our domain for tangent has to be greater than pi over 2 greater than negative pi over 2 less than pi over 2. So this is saying our hunt needs to go from negative pi over 2 all the way up to pi over 2. In other words, don't investigate that quadrant or that quadrant. Where could tangent be positive? Not here, because all students take Calc. Cosine's the only thing positive down here. So we know we're stuck in this quadrant, and the only way you can have the opposite and the adjacent be equal is if this is 45 degrees. For the 45, 45, 90, these two sides will always be the same. So there's our answer, 45 degrees. Now in terms of radians, what is it? That would be C. Okay, so number 13, very similar to number 12, but this time we have cosine. Cosine's domain, our spinner, greater than or equal to 0, less than or equal to 180, or pi. So that means it can be anywhere in here. But the question is, where can cosine be negative? Definitely not in the first quadrant. So we need to think, where could the adjacent side be negative square root of 3, because that's what goes in the top. And our hypotenuse is 2. Well, if we drew the drawing, negative square root of 3 here, and then our hypotenuse is 2, that would make this a 1, which would help us understand, let me move this a little bit, that this would have to be 30 degrees, which tells us we'd have to flip our spinner 150 degrees, and as once again, not given to you in terms of degrees, so we need to know what this is in terms of radians. Well, the way I would think of it is 30 goes into this 5 times. So if pi over 6 is 30 degrees, we'd have to multiply this by 5 to get this. We'd have to multiply this by 5 to get the radians. So it'd be 5 pi over 6, and that would be letter E. So number 14, key to this problem is they tell us angle C is 90. I've got that drawn over here. And then it says find length B right here. Well, they also give you the angle of angle A is 40. So we're going to take advantage of this. See, if they give you a 90-degree angle, you are allowed to use sine, cosine, or tangent. So let's take advantage of one of these. Well, if they're asking for side B, and we're going to use this as our reference angle, that would make this our adjacent side. We know that this is our hypotenuse. And what trig function uses adjacent and hypotenuse? That'd be cosine, because of SOHCAHTOA. So we would go cosine of 40 degrees equals the adjacent, that's what we're looking for, over our hypotenuse 18, and now we've just got a math problem to solve. So I just found cosine of 40 degrees on my calculator. Make sure you're in degree mode. 0.766 equals b over 18. Multiply both sides by 18. And the final answer would be 13.78. So we go looking through our answers, and looks like B is the closest to that. You're going to have to do a little rounding on this exam. So very similar to the previous problem, we have a 90-degree angle, angle C. They stick with angle A being 40, but this time they give you side A, and they ask you to find the length of side C, which is your hypotenuse. So if this is the angle we're going to concentrate on, that makes this the opposite side. We know that this is the hypotenuse. What trig function from sine, cosine, tangent uses opposite and hypotenuse? That'd be sine. So I'm going to go sine of 40 degrees equals opposite over hypotenuse. Now a lot of students freak out a little bit when the variable's stuck in the denominator. But I'm going to go ahead and figure out what sine of 40 is. That's 0.642. So I'm going to write that over here, 0.642, just 0.64 is probably good enough, equals 3 over c. Now again, if c is buried, you got to multiply by it. Get rid of it. I got to multiply this by c, so I get 0.64c equals 3. So I got to divide by 0.64, divide by 0.64. Give me a second. And the answer would be 4.68. So I look for 4.7, and there it is, letter D. All right, so number 16 is coming at you from a little different angle, no pun intended. It's asking you to find the measure of angle A. So we're going to throw our theta right in there. We're going to identify this as my opposite side, identify this as my adjacent side. That should trigger what to do. So we're going to go tangent of that angle is equal to opposite over adjacent. So I use my calculator to figure out that 11 over 14 equals 0.785. And this we're going to go second tangent and then enter that. So second tangent, 0.785, enter. I got 38.1 degrees. 38.1 degrees. So we look for our answers. 38.2, close enough. We did a little bit of rounding. So number 17, we got the story problem about angle of elevation, which is right here. And then from a boat, so I got the boat here, to a hovering helicopter. Helicopter is right up here, 49 degrees. The horizontal distance between the boat and helicopter is 60, so that's this. What's the altitude of the helicopter? So that's this. So here's our reference angle. That makes this my opposite side. That makes this the adjacent. So once again, I'm going to go tangent of 49 degrees is my opposite side over my adjacent. I'm going to look that up. Tangent of 49 is 1.15 equals x over 60. So I'm going to multiply by 60. Multiply by 60. 69.02. So we're just going to say it's 69. And it looks like it says approximate. So we're going to have to round 69 to 70. Okay, so number 18 requires maybe the most work on any problem in this entire exam review. So they give you a random triangle, 4, 7, 9. First decision you have to make is this a right triangle? The answer is no, because if you went a squared plus b squared equals c squared, it wouldn't work. Plus you could say back in geometry, 3, 4, 5, 5, 12, 13. There is no 4, 7, 9 family. So don't you dare assume that there's a 90 in here. So we cannot use sine, cosine, tangent. No. So that's our first option. Second option, law of sine. So we know that sine of A all over A equals sine of B all over B equals sine of C all over C. And if you remember, guys, we have to know well, first of all, you got to know the law of sine. Second of all, you got to know that you only need 2 of the 3 fractions, and then the 2 that you pick, you need 3 of the 4 parts. I know that's a mouthful, but we don't have any of these angles, so we can't use the law of sine. Now, in your formula sheet, they give you the law of cosine. They only give you one choice, so we're going to work with this, and it's asking us to find the largest angle. Well, if this is the largest side, that means they want us to find this. So because this has angle C, I'm going to call this angle C. So it just conforms to our formula. And I'm just going to randomly call this A and call that B. I could have flip-flopped these. It doesn't matter. I'm sticking with this. So C squared would be 81. A squared is 16. B squared is 49 minus 2 times A, which is 4, times B, which is 7, cosine of C. And I got to whittle this down. 81 equals 65 minus 2 times 4 is 8, 8 times 7 is 56, cosine of C. Now don't make the dreaded mistake of subtracting 56 from 65. See, for years and years and years, you guys have been doing problems like this, and I hope by now you would never think to make that 6x. No, 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 no. So don't you dare go 65 minus 56, because this is 56 cosine c. So we have to subtract 65, and so we get 16 equals negative 56 cosine c. Divide by negative 56, divide by negative 56. Give me a second. And now I've figured out that 16 over 56 is negative 0.285. And now I got to go second cosine and then figure this out. So after taking second cosine, negative 0.285, I get 106.5. And it looks like option C is the closest to that. So there we go. C it is. Okay, so number 19 gives us a whole bunch of information. I've got it drawn right here. One thing that jumps out at me, I see 150 and 8. It's 158. If we subtract that from 180, we can get 22 degrees down here just by using good old geometry. Now I can see that I have this angle and this side, this angle, and this is the side they're asking us to find, so that I can use law of sine. So I'm going to go sine of angle C all over side C equals sine of angle A all over side A. And now it's just some number crunching. So let me take a second and figure out what those are as decimals. Okay, so I figured out sine of 22 is this. Sine of 150 is this. So now I'm going to cross multiply here. And I get 1 equals, and I cross multiply here, 0.374a. Now I got to divide by 0.374, 0.374, and I get 2.67 for a, which is letter C. So for this problem, I'm going to take a look at it. Do I have a 90-degree angle where I can use Pythagorean theorem or something? No. My next option should always be, can I use the law of sine? And as you notice, I have this angle, no side. I don't know this angle, I know the side. I don't know this angle, I know the side. So that doesn't allow me to use the law of sine. So I'm going to have to use the law of cosine. Now it says find the approximate length of C. I've got the law of cosine written right here, so I'm not going to rewrite it. So I'm going to say, all right, well, this is my side C. So C squared equals A squared, which is 16. I'm just squaring this. Plus B squared, which is 81, minus 2 times A times B cosine of angle C, which is 25. And I just have to figure out what this mess is. 81 plus 16 is 97. I'm going to go ahead and figure out what this is. Just give me a second. So I went ahead and worked on it. So I figured out that this whole thing right here equals 65.25. Subtract it from 97. I get C squared equals 31.74. Then I take the square root of both sides. I get C is 5.6, which is option A. So number 21 is a little tricky right off the bat because they only give you this in the formula sheet when there's actually 3 different versions of the same thing. And if we tried to use this one, we'd say, all right, we need side A. We don't have it. We need side B. We got that. We need angle C, and we have that. So we'd say, oh, we got to find side A. And then you'd get sucked into using law of sine or law of cosine. Here's the trick. We know side B, and we know side C, which is saying, okay, we got those two sides. Be nice if we knew what angle A is. And we're like, oh, darn it, we don't. But yes, we do. 100 plus 38 is 138. We subtract that from 180, we get 42. So it's a little tricky because they only give you this. So if you want to add this and this to your formula sheet, go for it. So now we can fill this in. 1/2, what's B? 15. What's C? 10. And we go sine of 42 degrees. So what I did to simplify this was I found sine of 42 is 0.669. 15 times 10 is 150 times a half is 75. 75 times this is 50.2. And we're going to take a look at that and just say, well, this is the closest. I wish they would made a little bit more